already down to our last sample problem number 5 for module 7, curvilinear motions. Okay, the car is traveling along the road with a speed of v is equal to 2s. Again, if you see the velocity function, it is a function with respect to the position. No? Dili siya katong issue na to nga time nga t and natin ginagamit nga t. So this is the position s, where s is in meters, so this is in metric. Determine the magnitude of acceleration when the distance or position ni car is at 10 meters from its starting point. Okay. So, sa ibato na ito diri, magnitude of the acceleration. So, itong isulat ang given. So, itong velocity is equal to 2s. And then, we have s is equal to 10 meters. So, gain na ni relationship ni tangential acceleration natay v dv is equal to a ds. So, para makuha na to si tangential acceleration, we just variable separable the velocity times the derivative of the velocity with respect to time. So, mara niyang pasabot ha. So, ito ang v is 2s. So, ito ang derivative of the velocity will be just equal to 2 with respect to s, of course, with respect to position. It will become 2. So, ito yung substitute here. We have 2s times 2. Then, ito tangential acceleration is just equal to 4s. But naman tayo s nga given, which is 10 meters position. So, 4 times 10. And we have a tangential acceleration equal to what? 40 meters. Next, para makuha na to is the normal acceleration. Normal acceleration is equal to v squared over rho. Pila si rho na given na to nga rho, 50 meters. So, kung wala, dili gibutang na sa drawing sa makita. So, v squared, the square of the velocity, so 2s. So, kabalot nga ang 2, nga si s is 10 meters. So, 2 times s, 2 times 10 is just 20 meters per second squared. So, 20 and then squared kay v squared over rho. Pila si rho? Again, 50. So, ito ang normal acceleration will just be equal to 20 squared divided by 50, 8 meters per second squared. This is 40 meters per second squared. So, kung ano na to atong magnitude, with the same formula, substituting the value, tangential acceleration, 40 squared plus 8 squared. Our magnitude of the acceleration will just be equal to 40 squared plus 8 squared. 40.792 meters per second squared. So this will be our answer for the sample problem number 5 using the curvilinear motions. Okay, before we end this topic, gamay lang review again. So curvilinear motion and normal and tangential components. So actually, ingon nila nga ang projectile motion is just curvilinear motion also. But instead of using the horizontal and vertical component of the velocity and the acceleration, in the curvilinear motion, duha mga motion na itong gina-consider anin ay horizontal na apoy vertical. So na vertical then na apoy horizontal. So to make it easier, we use the normal and tangential component. The normal component is katong, if you see here, if this is the curve, na siya radius, no? So the normal acceleration is katong directed towards the center or the center point of the curve, or same siya sa radius. And then the tangential acceleration is always tangent along the path that is 90 degrees with the normal acceleration. Direction of the tangential acceleration is just the same with the direction with the velocity. And so, ato ang acceleration dayon sa curvilinear motion is mao ni siya si A, which is equal to, ato i-discuss later. Again, si rho is just the Greek letter rho, which denotes the radius of curvature. So, changes unless the path is circle. So, the velocity always acts tangent to the path, as akong sa giingon, and then always perpendicular with radius. One, perpendicular with the normal acceleration. So, kaning A sub t mo na siyang tangential acceleration, A sub n, this is the normal acceleration, and then the A lang gani is magnitude of the acceleration or just the A. So, this is our curvilinear equations. So, magamit po natin itong kinematic equations, no? Nga constant acceleration and non-constant acceleration. Pero naay nadugang, no? Tangential acceleration, A sub t, na siya gidenote nga mura siya katong same sa velocity, no? Nga V, but na siya murag dot sa ibabaw. But ay na kay problema atong self, we can use this symbol for the tangential acceleration. And then for the normal acceleration, A sub n is just equal to velocity squared over rho. So the velocity here is nag-denote, diba, sa module nga or v times ut. So this is only a unit vector. It represents that the velocity is moving along the tangential, tangent to the path of the motion, ng u sub t. So magnitude of the acceleration, using this graphical method, the acceleration mo ang magnitude sa acceleration is equal to the square of the tangential acceleration plus the square of the normal acceleration. So muna na siyang naka-Pythagorean theorem. So this is a scalar quantities. If you were asked the acceleration, considering the vector in its vector form, then we can use this. A is equal to at u sub t. So wala na siya value again. It only shows which direction or path is this acceleration is, and this normal acceleration. So u sub n is a unit vector. It means that denotes a normal component. So here, u sub t denotes a tangential component, and then u sub n denotes a normal component. Radius of curvature of any path, so ato ang rho, radius of curvature, if we are given a function of the curve, it's just this equation, no? The quantities of 1 plus the square of the first derivative. So dy over dx is the first derivative, or y prime squared, and then raised to 3 halves, all over the absolute value of the second derivative, d squared y over dx squared, in prime notation, that is y double prime or y second prime. So that is all in our curvilinear equations. And if you have any questions, feel free to message and PM me for any clarifications, so you can understand more about the subject.